Hi, everyone. We are at the PagerDuty Summit, and I'm very excited to present the work we are doing in the field of machine learning and AI. My name is Mitra Goswami. I am the Senior Director and the Head of Machine Learning and Data Science at PagerDuty. I have been a developer and a researcher coding in C++ during my astrophysics PhD days at Northwestern. I have also been a data scientist and a data science advisory consultant to executives before jumping onto the management positions. And I love AIOps because AIOps is a tool for the developers. And I'm going to explain in my talk why AIOps is such a powerful tool. I spent most of my time now working in AIOps and creating cost-effective machine learning and AI solutions in the industry. In my talk today, I'm going to cover the definition of AIOps, what PD is doing to power AIOps. Then I'm going to dive deep into root cause and why is root cause such an important avenue to help developers. And then I'm going to end with highlighting some of the cool new features that we are presenting for the first time in Summit. So what's the definition of AIOps? What is AIOps? Gartner in 2016, they coined the term AIOps. And at that point of time, AIOps was something new in the market. Fast forward a few years, and in 2021, Gartner said that there is no future of IT operations without AIOps. Although the definitions vary. So if you read the Forrester definition, the IDC definition, and the Gartner definitions, the definitions vary, and there are different approaches. AIOps has become a very important tool for everyone, for all the developers. So how does PagerDuty power AIOps? When we started this journey some time back, we took some time to align on the definition of AIOps for PagerDuty. And we talked to our customers. And when we are talking with our customers, there were three main takeaways or three main pain points that our customers tried sharing with us. We asked customers, what is the most important part that you are looking at when you are trying different AIOps solutions? And they said ease of deployment is very important. This is huge. While some of the available platforms like MoveSoft and Big Panda require weeks and sometimes months, and maybe even a POC, PagerDuty is extremely easy to implement and get running very quickly. We also have extensive solutions and documentations, and most of our customers see results almost immediately after our setup. So that's number one, the first customer challenge. The second and the biggest pain point among all our customers is not being able to quickly discover the root cause of an issue. And root cause has a direct impact to MTTR. And when we look at root cause, why is it so difficult for our developers to identify root cause? I'm going to describe why it is difficult, and I'm going to describe the threefold solution that PagerDuty has adopted to solve the root cause problem or to recommend root causes to our developers. The third pain point is that customers want to trust AI and machine learning solutions. They are making crucial decisions depending on the black box available, and they want to be able to trust those black box solutions while trying to make a crucial decision. So that takes me to the developer pain points. So, root cause, I explained why it is so difficult, why it is so important to identify the root cause or to recommend the root cause while we are triaging for incidents. However, why is it difficult for developers to solve for root cause or to recommend a root cause themselves? Why do they need an AIOps solution? The reason is that when an incident hits, during that time, developers get hundreds and sometimes thousands of alerts. And at that point of time, it is very difficult to look at relevant and useful information. You can almost call it an alert storm or alert cyclone. And at that point of time, since even time is crucial, it's very important to look at relevant information. The second point is that developers are lacking some of the high-level context as they are looking through different alerts. Because once again, when an incident hits, the trigger might be a specific set of distinct events happening over a period of time. However, if human eyes are not able to identify the correct window of time and only looks at a narrow window, they might lack some critical context. There is also communication loss because maybe human eyes who were present at one day are not present the next day, and therefore some critical context is getting lost over time. The third pain point is unable to relate previous changes to incidents. We know at this point of time, 80% of the incidents are driven by change events. However, it is so difficult to relate active changes and historical changes to those incidents when the incidents are happening, because of the fact that all the coherent information are not at the same place at the right time. So for these challenges, developers are delayed to identify and locate the root cause for specific incidents, and they need help. They need an AIOps solution to make sure they are able to recommend a root cause as soon as possible. PagerDuty's root cause analysis is kind of based on a threefold approach. So recommend, repair, and optimize. And recommending root cause is a very crucial step in this journey. Our goal, once again, is to make sure that developers can address root cause and can go back to innovating as soon as possible. So this is the last slide in my first section, where I kind of describe, or I kind of relate an efficient RCA to an efficient developer life and efficient developers. And I want to describe PagerDuty's AIOps vision, which says that we want to reduce toil so developers can spend more time innovating and not playing detective. This brings me to the core versus chore, or the working above the value line. We want developers to focus on the things which are most important and not look at alerts which are not important, not look at everything, all the other information which are not relevant at that point of time. So an efficient RCA has a direct impact to the days and lives of developers. Faster root cause analysis reduces MTTR, mean time to resolution, and has a direct impact. Faster root cause analysis also avoids unnecessary burnout. And remember, these are stressful situations when developers are trying to find out what's the right step, what's the right way to solve a problem. Hence, it is very useful that we actually recommend our root cause such that developers can get the right teams together, can focus on the right information, and can select the alerts that are only useful during the alert storm. This kind of takes me to the second section of my talk, which is recommending the root cause. And I'm highlighting the fact that I'm calling recommending because root cause, it's very difficult to pinpoint the actual root cause. However, we can help the developers. We can aggregate the alerts together, the relevant alerts. We can say that, hey, somebody have received this alert or have seen this alert before. So be aware, this is a solved problem in your field. Or we can say, hey, this alert occurs 60% of the time, so solve this issue. So we are kind of trying to help developers rather than pinpointing to some particular information. So PagerDuty has a threefold solution to recommend root cause. The first is reduce noise. As I said, during an alert storm, life is very difficult, and we need to take away all the noise and kind of aggregate similar alerts. So our solution is based on aggregating similar alerts, merging related incidents such that during an incident when tens and thousands of systems start alerting, developers are not inundated and can focus on what is important and relevant. The next one is classifying incidents. So how can AI be used to classify incidents as frequent, novel, or rare? This is related to the fact that we are trying to provide some critical high-level context of what has happened before to our developers so that they can find something familiar, and in other cases, they would know that, okay, this is completely new and I have no clue and I need to focus more time here, or I need to get more people in the room. The third one is relating to changes. So how can AI correlate changes to incidents? And here I'm talking about active changes, I'm talking about historical changes, and I'm talking about change windows, because as I have said, there are things happening in order, and if the change window is too narrow, we might not be able to recommend the right root cause. So we are working with 3 different changes which have happened in the past, active changes, real-time changes, and the change windows. The first solution that we have is intelligent alert grouping. Intelligent alert grouping is available in the event intelligence package and also available on our digital operations plan. So what is the problem that we are trying to solve? Teams can't scale without the rising complexity of their systems. And during an alert storm, if they have to look at thousands of alerts which are not useful, there is alert fatigue. And alert fatigue hurts morale and makes it hard to identify what's actionable. So what's the solution? As I have discussed in the previous slide, PD is trying to use AIOps so that we can help developers. Our reinforcement algorithm learns ways to group alerts from both inbound signals and responder behavior for customer historical data without any manual intervention. So all the algorithm does is looks at historical data and figures out, okay, hey, the responder has behaved in a particular way in the past, and can we learn from that information? Hey, you have received alerts like this before, and can we learn from that information? And can we group things together? Can we cluster things together? So if you look at the dashboard on the right side, you will see that this particular incident has 33 alerts that specifically that happen specifically because of this incident. And we have all the alerts at the same place at the right time. Hence, we have coherent and relevant information to help our developers during a triage process. The next one is the incident outliers. This is a feature that we are showcasing in our summit for the first time. What is the problem here? Once again, responders are heads down in response effort and they lack critical context. And we are trying to provide them that historical context. What is the solution? Our solution is that we have an optimized, unsupervised model to classify incidents as rare, novel, or frequent. If the incidents are frequent, as if you look once again on the right in this dashboard, this event is tagged as frequent. So if we know that an event is frequent, we can give information to the developers that, hey, this problem has been solved before. So can you get the relevant parties in the room? Can you ask someone else who has worked on it before? Beside the tag, you can also see that it says it happens 50% of the time. This information is also very critical to developers because then they would know that they need to fix the error because they're getting incident based on this error many times now. So this is our incident outliers feature. This is a new feature. The third feature that we have is change events and correlation. Once again, this is a new feature that we are showcasing in Summit. What's the problem? Responders are unable to relate change events to incidents. And what we are doing is we have an optimized, unsupervised model that looks at the historical data for customers and also looks at active changes. And then we can move around our change window. And we are trying to correlate changes to incidents. If you look at the right, on this dashboard, you can see all the recent changes and then the incident being tagged to the changes which are critical. So for example, we say that this incident has occurred 10 minutes after this change. This is also kind of suggesting or recommending the change events which are most critical to the incident, such that our customers can identify the likely change causing the incident. So I want to highlight here that we are not only showing the changes, but we are also recommending the most likely change which would cause this incident. So these are all the 3 different AIOps tools that we have currently in our platform for developers to be using them and trying to find the root cause of an incident as fast as possible. I'm going to conclude my talk here. And before I finish, I would like to highlight some of the conclusions that when it comes to AIOps solutions, ease of setup and deployment is a very important criteria. PagerDuty is extremely easy to implement and gets running within minutes. Our machine learning algorithm has results in minutes. So we have kind of solved the first problem. The second problem is the biggest pain point, and it's kind of identifying and the probable root cause of an issue in order to reduce mean time to resolution. At this point of time, PagerDuty is heavily invested in a 3-fold AI solution to recommend root cause. And we have 3 new features in our platform. The third one is that, this is interesting because the need to embrace AI has made our customers very eager to trust something that they might not even know what's happening, to trust something which are kind of helping them in making a very crucial decision, but they are not fully aware of how the black box is making them or driving them to make that decision. So that brings me to what's next in our roadmap for AIOps at PagerDuty, and that is explainable AI. So we have an approach towards explainable AI. Our analytics platform is huge. It powers more than 13K customers, 600K users, and we have 10 years of data available to us. So we are going to leverage the strength of our analytics platform to kind of show the growth, the feature-led growth using an AIOps solution. That's number 1. Number 2 is that our, you believe in what you see, and our algorithms are up and running in minutes, and you will be able to see that they reduce false alarms immediately, 50 to 60% of false alarms. So that is kind of the first step in building trust. And what we are doing now is, as we are building new machine learning features, we are introducing hybrid ways in which we can interact with the customer. We can ask, or we can incorporate some of the institutional knowledge that our customers have in our ML platform, so that our ML recommendations, ML and AI recommendations can be tweaked, can be changed, and we can incorporate some of those institutional knowledge, and they become more robust with time. And our users can see those changes, can tweak those changes. So we are giving more power back to the customers and making them trust our AI solutions. Thank you for listening to my talk. It was a pleasure talking about the machine learning and the AIOps solutions that we have at PagerDuty. If you have any questions, and if you would like to know more about these features, come visit my team at the PagerDuty AIOps booth. Thank you very much.